I know there's a lot of moving pieces for the class, and so from now on, I'm going to try my best to keep the website updated. And so now if you go to the website, the main website, and if you go to lectures, the lectures tab, what you'll see, you see these tabs, right, where we have the live code link, the screencast to the YouTube if you want to watch it or if you miss class. And then I'm also linking to the Google Doc. So now you can find this all in one place. So we'll still have the little tiny URL. We'll set that up. But from now on, if you're never sure where stuff is, it's all going to be here. So if you click on the live code, it should take you right to this, right? And if you refresh, you should see that code. And if you go to the Google Doc, it should ask for, if you're already logged in, it'll just pop up. Otherwise, it'll ask for your password, your UC Davis stuff, okay? So I just want to let you know that's all there. And then the screencast obviously is here. I'm not going to click on it or we'll go into some weird alternate universe. So that's that. Any questions on that? Cool. All right. So let's jump in. I'm going to show you a couple of really quick things that we kind of have forgotten to cover that I think are important just from helping folks on and off. So I'd like everybody to open up RStudio, if you haven't already, into the project that we've been using, the week 1, whatever it was. Next week, I think we're going to probably start a new repository, but for now, we're going to use the same one. And I would like, first off, I would like everybody to go to Tools. And then we've looked at some of these before, right? What I'd like everybody to do is really quickly uncheck this box right here where it says restore.rdata into workspace at startup. This is one, there's many discussions online about this that you don't need to go read, but I'm going to tell you about. One of the things that this defaults to is that box is often checked. And the problem is that when you start RStudio, it will load stuff up for you from whatever you've saved. Can anybody come up with some ideas why that's maybe not the best sort of pipeline of data analysis to use? Sure.
You're collaborating, then you don't pull stuff off GitHub first.
Right. It loads things before you've sort of like brought your changes in. Anything else? What if, yeah.
You have variables named.
Exactly. That one I think is the key one that often happens. And that happens even when you're not doing, when this doesn't happen. You can overwrite variable names and not necessarily realize you've done that. And then you have a new data set suddenly that's not representative of what you thought it was. So in all cases, just the general principle of things, you should always start with a clean tablet, right? A clean sheet. And to do that, you don't want to have any data loaded. You don't want to have anything that shows up without you explicitly saying, I want to load this, I want to do this, I want to do this, because that makes it repeatable, right? That's the whole point of, if you send it to somebody else, they can do A, B, C. So let's uncheck that. Workspace R data on exit, I click never. The reason being, there's like ask, I think is the other option. Yeah, always or never or ask. I click never just because it's annoying to always have to click no every time when you close RStudio. And the reality is you should be specifically saving different pieces of data, and we're going to start doing that today. You will be saving things and putting them where you want. These R data files we're going to talk about are really cool, but you need to use them sort of in certain ways. It basically is a way, imagine you have a spreadsheet of data, right? And then we go take that data and we sort of crunch it down and pull out just the pieces we want. We filtered it, we select what we want, and then we want to save that data. Well, we've talked about saving to CSV is sort of the standard primary way. But one of the other ways you can do, or one of the other things you can do is save to these R data files, .rda or .rds. There's 2 different kinds. Those basically keep the formatting all nice and tidy for you, so you can load things up and not have to sort of run code to make it formatted and do things. It keeps it exactly how it was when you had it in R. So they're really handy and they're very compressed as well. So you can take, like what would be a 10 megabyte file in Excel, and it will be like under a meg in an RDA file typically. So anyway, they're really handy. You can save multiple things and put them all in one. But cover that later. So anyway, uncheck that box and put that to never. And then hit at the bottom here, which I can't, I wonder if I move this, can't actually get to that screen. Hang on a second, there we go. Hit apply or okay, either one will work. And then, oh, the one other thing I wanted folks to do is if you, or do we want to wait on this? We get config. We're going to do that at the end. I'll shut up now, and Taylor's going to take over, and I'm going to eat a cookie.
Okay, so last week when we started talking about R, we got through some of the beginning of the basics. So for instance, we learned that you can use R as a calculator by typing things like 12 plus 3. That'll get sent to the console, and we see that that's 15. And we saw that we can do some object assignment as well. So something like, let's say 15 stood for a temperature in Celsius. We might call this temp, and then do 12 plus 3. And now we have a variable when if we call temp, we run this with command enter, then 15 comes up as well. So when I'm running these sorts of things, there's a couple different ways that you can produce sending code from your source file, which is over here, to your console, which is up here on the left. The first way is what I've been doing is if I come back up here on the line, I can press, if I'm on a Mac, command enter, and then if I'm on a PC, it's control enter, and that runs the line of code. Or you can come up here and you can press, I think this is the run button here. Oh, that's not. Oh, I'm looking at the screencast. Interesting. Here is the run button. And that will run it as well. Okay. Did anybody have any questions about these first few basics before we launch into the different data structures that are in R? Okay. So this first thing called temp, actually, let's annotate our code. Let's not be sloppy. R can be used as a calculator. The results of computation can be assigned object. You can take shorthand notes. You don't have to copy all of my notes. And then this object can be called. And so when you start saving things in objects like this, that's called a vector. So vectors are one-dimensional things that store information in them. But importantly, the information all has to be of the same type. So let's go over what that means. So I can do something similar to temperature. I can do weight kilograms and assign that to the value of 55. Or if I wanted to save multiple values, I can use the C function, which stands for combine. And I could put multiple values in here. So 55, let's say 53, 62, and 71. And then let's run this. And then if I look at weight kilogram by running just it, and we see that all of those values are now combined together. So what happened between this line of code here and this one here? Now is 55, 53, 62, and 71. But what happened to this information that I had assigned here? I overwrote it. Yeah, so that information is now gone. I could come back up here, and if I rerun line 13, and I come down without running line 15, 16, then R doesn't know without me running it that line 15 is there. So I just reassigned it again to 55. So that's something to be aware of and to keep track of when you're doing these assignments is whatever you ran last is what R is going to remember. So let's run line 15 again and see what that looks like. So again, we have a vector now that has 4 elements of information, 55, 53, 62, and 71. So that's what it looks like for numeric data, but we can also do this for characters as well. So vectors can hold character strings. We can use our combine function again. And we can put different character strings in here like mouse, rat, dog, and cat. Do you have a question?
Oh, yeah, for some reason I'm not, my console isn't responding to what I'm typing in. Is that a common issue?
It can be. It just depends. Okay, so if we inspect what animals looks like as well, we now see that this is also a vector that has 4 pieces of information, but these are all character strings now. So what looks different between the output of this line of code up here and this one here? What's one difference?
Everything has quotation marks.
Yes, everything has quotation marks. So that's really important when you're dealing with strings, is that you have to put them in quotes, or R is going to think that you're talking about an object, and it's going to say, I don't know what you mean by this. And think that it's an object that you've already defined, and if you haven't defined it, then it will throw you an error. But if you put them in quotes, then it knows it's a string. And there are some useful functions to get information about these sorts of data types, so about vectors. So let's see. Yes?
What string?
Yeah. So a string is information that is stored as characters. So this is literal, where the meaning of the first piece of animals is the word mouse. If it was an object, then mouse could be defined as something like 15 or anything other than that. But when it's a string and it has something to do with words, and it's the information itself is composed of characters, then we can call it a string. So it's the type is character, but the shorthand slang for it is string. So, for instance, if I had a text file, let's say Jane Austen's books, and I read in each chapter as an object, the information that makes that object would all be composed of characters, so I could call them strings. Yes?
Can you save the script?
Oh, sorry.
Now if you refresh, it should show up.
Thanks. Is that clear, or should I try a different explanation?
I think
You'll get there?
I'll get there. Yeah, thank you.
Okay. So let's find out some ways so that we can get information about these vectors that we have. So I can find the length with the function length. If I want to know the length of animals, comes back as 4. What would the length of weight kilogram come back as? 4 as well, yeah, because it also has 4 pieces of information in it. Okay, but there's also something called class. And if we run that for weight kilogram, we get back numeric. What do we think that means? Yeah, the type of data that's in the vector. So let's try that also for animals. And we see that this type of data is character. And then we can also look at the structure. Yes.
I was wondering, so like once we've saved animals as a vector, when we start to type it again, it comes up with like 2 options, like a little, I don't know if everyone's icon's the same color, but animals with a tan label and animals with purple label. What's the difference between those 2?
Let me see if I can get what you're getting.
Oh, when you type animals, you hit tab.
Right.
Yeah.
So I get only the purple label. And you get 2 labels? Does everybody get 2 labels?
I only get the purple. I get 2.
So this is referring to which variables you currently have in your environment. So let's get a cheat sheet for that. So down here in this console here, in this section of RStudio, we have a tab called Environment. So I'm going to go there. Can you put up a green sticky if your environment looks the same as mine? So some people, everybody's looks like it looks the same as mine. Does anybody who has 2 animals pop up here not have the same environment as mine? Okay, so what's happening here is that R is keeping track of the objects that are in the environment. So we've saved something called animals, which is a character vector that has mouse, rat, dog, and cat in it. We have temperature, which is 15, and we also have weight kilogram, which is a numeric vector that has 4 values in it as well. R is keeping track of that, so when you start typing it, it comes up automatically, and it tells you a little bit of information about it with this icon. If you're getting a different icon, it might mean that you have a package loaded that has a function in it named animals that you could call that.
There's a cluster package that has a function.
Oh, okay. So then you have the cluster package loaded into your environment, so you could run the function animals. Where versus I don't have that loaded in my environment right now. So the only thing that R is aware of is this animals vector that I created. So let's tab complete something else. So we'll go back to the structure commands in a second. So let's see if anything starts with Z. If I press Z and then I press tab, this can give you a hint as well. So zap small is a function that's in base R, which it's telling me here from utils. And then we also have different packages. So the blue icon indicates that it's a function, and then the P icon indicates that it's a package. And that's also what these 2 little dots indicate as well, that you could be calling a package. So tab complete tries to give you a lot of different information about about your environment, about the things that are available to you that you could do computation with in R. That was a good question. So I think you have the cluster package. Was that what it's called, cluster?
ones too, but then if I run both of them, no matter what color tab or whatever, it gives the same return value.
So, okay, so what she's saying is she also has the two animals, but no matter what tab color she clicks, it gives the same return value.
And for weight, kilogram, and
Yeah. So I'm not sure about weight, kilogram, and temperature, but the thing is that depending on what syntax you use in R to call the data that you're trying, the code that you're trying to interact with R with, R is going to know what you're talking about. So for instance, this is the syntax of defining a vector or getting information about a vector or an object. If, for instance, animals was a function instead, have two parentheses after it. Because whenever you're using a function, even if it doesn't have arguments, it's almost always followed with two parentheses. So it knows that you're talking about the vector because of the syntax that you're using. More questions about that? Okay, so let's look at one more function to examine what's going on in your vector. You're confused, your colleague just gave you weight kilograms and you don't know what it is. You might look at the structure using the str function. So if I run that on weight kilograms, we see that it tells us that it is numeric. It has indices 1 to 4, meaning there's 4 pieces of information in that vector. And then it tells us the first couple values. Because our vector is only 4 values long, it tells us all of the values. But if it was 4,000 long, I think it would only tell us 6 of the values. And we can do the same thing for structure animals. And they look pretty similar, but the data type is different because this is character. So the other nifty thing that you can do is once you have data stored in an object in R, you can combine them together using that same C function. Let's do that for our 2 vectors. We won't save this to an object just yet, but we can combine weight, kilograms, and animals. And now I see that I have a vector. It looks like we have 8 pieces of information in it. See something that happened that's different about this data that one might want to be aware of? Now the numbers have quotes around them. So that's something to keep in mind, is that whenever you're dealing with a vector, it always has to have the same type of data in it. So because we saw that animals was character and weight kilograms was numeric, character cannot become numeric because that doesn't make sense. But we can put quotes around our numbers and those can become characters. So that's what R did. Into characters. So what would happen if we tried to add together? No, we'll get to that later. We'll come back to that piece. Okay, questions about that before I reveal to you all the other types of data structures in R? Okay. Let's brainstorm what they could be. What is something that would be useful other than a character and numeric to have as a data type in R? Yes. Yes, that's the last one that we're going to come to. What about the basic ones? Integer. Integer, yes. Integer is different than numeric.
Variable.
Okay, yeah, so all of the objects that we are defining are essentially variables. You can think of them as variables. So if variable is up here, this is like the class of variable that we're talking about. That's a good clarification. Did you have one? Logical. Logical, yes. So true, false, or Boolean. That one's really important. So we have numeric, character, integer, and logical. And then I'm going to give away the other two. The second to last one is complex. So if you take the square root of -2, chances are you won't be dealing with that one too frequently, but when you get a complex number. And then the last one is raw, and that has something to do with like computer bits. So like how computers talk to each other. So also something that you might not be dealing with super frequently, but it's good to know that it exists.
Can you type those in, the types?
Yes.
Thank you.
So we had numeric, integer, Boolean, character, complex, and raw. And I think this brings us to our first challenge, but I have to check. Whoa. Ryan, where did the file go? The class file. So course materials, lectures, week 3, Google Doc? Yes.
Yeah.
Okay.
You got it?
Yes. Okay. So the challenge problem that is under intro to data, please, with the person sitting next to you or in groups of 3.
On the website. We'll pull that up. We are Data Frames Ecology, right?
I paste it's right there.
Okay. Oh, in the Google Doc too. I was going to put it on the screen.
Oh,
but,
that works too.
under which one? That one? Or
No, the second one.
You can navigate.
What is where? No. Just do the one that's in the Google Doc.
That's a different one.
Yeah.
It's on there. Okay.
So
Sorry, the Google Doc is on there too. The upper left. There you go.
okay. Here we go. Did they tell you what the problem was?
No, I found some words. It looks like other people have had the same issue, but I've been unable to resolve it. So I don't know. People can ask.
Restart your computer.
Highlighted.
Is it distracting when that happens?
What?
When it gets highlighted so many times?
No, it's just funny. That's just, people are, it just keeps changing colors.
Oh, okay.
Taking off it.
Let's see. Yeah, that's
Yeah.
Yeah. I'm just doing. Are you doing class? Yeah. Because then this is so it's logical, so it's numeric, so probably first one character over Oh, so it turns this to true or false. It turns it to
Here,
The second one.
logical.
Turns them on to.
Yeah. So that means that.
It's turning true into.
Because
Oh, it's probably binary. Right?
No, it's numeric. So it assumes that no matter what, true is. But it makes everything number not really even right? So like.
So that's what this is. So it's numeric character.
But it's true that the true false data is stored. So just say, or not,
Yeah. But it's starting true. But then you get a numeric. Okay, then for character logical, it makes everything a character. So that means that Boolean gets flipped to character.
Okay, so what happens with tricky? The last one. It still turns them all into characters. Okay. So is that what happened with num character? Num car, the first one?
Yes.
And the second one?
No.
What happened with the second one?
Numeric.
Numeric, okay. And what happened with the third one?
Character.
And then we said tricky was character. So why do you think this happens?
So it's kind of like it's fitting it into what it can fit into. So
Yeah.
If there is a character, it has to make everything a character. Easiest to fit everything in.
Yep.
And then for number and logical, it can make logical things into numbers, but it can't make them logical.
Yeah, exactly. So R is trying its darndest to make everything in a vector the same type of data. And it will always do that. So when you give it multiple types of data like we have here, it's called coercion. And typically that's something that you want to avoid. Or if you're not avoiding it, be very aware that it's happening. Okay. I will figure out how to navigate this computer. We put, oh, okay, this one, and then I grabbed that one. Yes, okay, we're back. Okay, so this is really wonderful. We can deal with different types of data in R. But what would be really handy is perhaps we have this vector now of weight, kilogram, and animals, but let's say I only want 71, or I only want dog. R has a handy little thing called subsetting that allows us to do that. I think I just, okay, sorry. Okay, subsetting. Okay, so let's look at animals again. And my favorite animal is a dog. The way I would do this is I take animals. So I tell R what I want to subset from. And then I start square brackets. And then I tell it the index of the thing that I want to subset. It's going to be 3. Because dog is the 1, 2, 3, the third index of this vector. And so that brings up another point about vectors, is they are ordered, and R keeps track of the index of every piece of information that is in the vector. So if I run this, I get only dog back. But that's not always terribly helpful. Sometimes I want dogs and cats. So I can use this handy little combine function again inside of our subsetting brackets. And I can say C parentheses because it's a function. And then I can say, let's say I want cat first. I can say 4, and then separate it by a comma, and then say 3 for dog. And if I run this, press Command Enter, I get the 4th index back first, which is cat, and then the third index back, which is dog. And this can also be used to make a vector longer if it is composed of the original information in the vector. So if I want more animals, I can take my original vector, animals, use my brackets to subset, my C function to combine things, and then I can tell it that I just want all sorts of animals. So I want the first one, which was a mouse, then I want the second one, which is a rat, then I want a lot more mice than rats because those are the ones that I like. And then I really love dogs, so I want to put a dog, and then another dog, and then another dog, and another one, and another one, and I don't like cats, so no cats. Sorry. And then if I run this, you can change your numbers to fit what you like. And then I type more animals. Tab complete will help me. I press Command Enter to run it, and now I have a mouse, rat, mouse, 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 dog, 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 dog. So it took the elements of my first vector and it made it larger. I can repeat them as much as I want and combine them together. Questions about that?
I just want to reiterate, if any of you are feeling like this is too slow, I had all of this, or if it's too fast, that's great. We're going to spend more time on this. But this stuff is really, really important to really fundamentally understand the different types of data. And I think it's really good to go through this stuff because later on, when things break, this tends to be the sort of thing you have to go figure out what R is doing behind the scenes. So it's really good to have a really good understanding of kind of what the different data types are and how R is going to interpret things when you mix them up. Particularly imagine you're bringing a bunch of ecological data in that has different types, right? You might have categories and numbers and who knows what else, and then you bring it in and you might not realize R is like trying to convert it to certain things behind the scenes. And so you need to really know explicitly like, hey, I want to make this vector this way, or I want to pull these pieces out. So anyway, I just want to sort of hammer that home because it is really, really important.
Okay. So I said before that we have Boolean as a type of data. So the cool thing is because we have that, we can do this thing called conditional subsetting. I'm going to make a new vector for this. I want weight in grams this time. Values. Using my combine function, I'm going to do 21, 34, 39, 54, and 55. These are small animals. And I run that, pressing Command Enter. And then, if I type weight G, setting, my C to combine things, I can use true and false to get back the values that I want. So in this case, I want the first, the third, the fourth, and not the fifth, and not the second elements. So if I line these all out and I run this, that's exactly what I get. So it's 21, 39, and 54, which aligns to 21, 39, and 54. So we skipped those two. Spelling out true and false like this is quite tedious. So this is actually not how conditional subsetting usually looks. What you could do instead is something like weight G, use the greater than sign, and say something like 50. And if I run this, I get back a set of values. So it tells me which is greater than 50. So the first one's not, the second one's not, the third one's not, but the last two are. And so if I combined this with what we were using before, our brackets for subsetting, and then I tell it that I want weight G that's greater than 50, I put a space in there, we get 54 and 55. So what that did is it took this greater than 50, which we got back as false, 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 true, true, and subsetted with that inside of our brackets from your original weight G to get back only the two values that we wanted. So this can be incredibly useful when you have really big data frames or vectors that you're working with. Conditional subsetting can also be combined. You can put multiple of them together. So what that would look like, we take above what we had, so weight G, our brackets. Weight G is greater than or equal to 30. And G, oops, G is equal to 21. It says error, object weight not found. Where is my syntax error here? What did I do?
Weight G.
Yep, so I forgot to do underscore G right here. So it says you didn't define weight. I can't do what you're telling me to do because you don't have that object. So I add my G, I run my line of code, and that didn't do what I thought it was going to do.
Can it, isn't that and? I mean, how can it be and? How can it be over 30 and equal to 21?
Oh, you're right. This is exactly what we thought it was going to do. It can't be. It cannot meet those conditions. It cannot be over 30 and equal to 21. So we would expect to get back a numeric vector with 0 things in it. Whoops. So let's do one that would actually work. Let's do weight G. Subsetting it, oops, again by weight G and less than 30. And then we can say or. So that's the straight up, that's the pipe, which is a shift and then above your return key, your enter key on the right hand side of your keyboard. And then weight G is greater than 50. Okay, so that gives us back something because there are things in this vector that meet those requirements. Okay. Yes.
When do you use double equals versus just normal equals?
When do you use double equals versus just normal equals? So in R, the double equals signals equality. So that's usually what, like in algebra, what you use the single equals for. That's what R uses the double equals for. And then the equal sign is used for assignment. And the way that we have been showing that equal sign is for assignment of an argument in a function. So let me show you that. So equals versus equals. Whoops. I'm going to leave that typo there for now. If we have a function like round, which I think we saw before, we can say x is equal to 3.14. So that's what we want to round. And then digits are equal to 1. We want to round it down to 3.1. So if I run this, that gives us 3.1. So here what I'm doing is arguments inside of a function. So we know it's a function because we're telling R to do something. And then we see those parentheses. And then the arguments are these things inside of it. So I am assigning values to those arguments using the equal sign, or versus equality is signaled with a single or a double equals. So for instance, what would we expect to get back if I said 14 is equal to 15? False. False, yeah. Let me fix that.
So it's the same values to arguments if it's the same.
So this can be kind of confusing because the other thing is I could say rounded pi is equal to round of of x is equal to 3.14. and digits is equal to 1. So I could do this. I can do assignment of an object with an equal sign, but Ryan, correct me if I'm wrong, that's essentially a style thing, and your code is easier to read if you use a single equals for argument specification and a assignment arrow for assigning an object. Does that make sense?
Yes.
Okay.
You will see code, but some people will still use equals as an assignment, but it's more generally folks are trying to get away from that because it can, because equals holds another meaning, right? And the assignment does not. So it's best to avoid it when possible.
That's a good question.
Yeah, a couple of questions.
Oh, sorry. Yes.
So the single equals defines an argument, is that what you said?
That's what, in our style guide, that is what we suggest using the equal sign to say what an argument, to define an argument inside of a function. So I'm defining x as 3.14, and I'm saying please use 1 digits by defining digits as 1, and I'm signifying those, the assignment of those arguments with a single equal sign. It's a style thing. It's not necessary. You don't even have to put x in digits if you don't want to, but it's really hard to read your code if you don't do that.
We'll start working with functions more as we go forward, and so you'll have practice and start seeing that. How's everybody doing? Quick check-in. It's halfway through, and I know we didn't take a break at all last time, and I want to make sure we take that opportunity. So are we at a spot maybe we can take a quick 5-minute break?
Yeah, that's a perfect spot.
All right, let's do a quick 5-minute break. People need to get some water and dress them, and then we'll come back in. No, I mean, so the other thing they covered this, they did.
I was like, how would they find it?
That would be cool. That's why I started doing it. She was really far.
Well, we can lesson plan.
So I'd rather than.
We'll still do signals.
Because then we're just right. We're gonna hit.
Do you have it on this message?
Maybe
It's like chaos, but yes,
First time I actually heard this, Tracy was a helper. Oh my god.
That's why I haven't used this, I guess. I'm just gonna turn it in for you. My friend just like sent me a Facebook message. Do you really wash things? My job, and I realized like there was not attached to it. I'm happy or yeah, well, especially because paper. Why? I guess
I know.
We are going to start a new section. Jonas, settle down, everyone. Guys, come back. Bring your back. Okay, we are going to start a new section. So I'm going to teach you some section black magic. So if you press Control, Shift, and R all at the same time, you will get a section label that pops up.
Or Command Shift R if you're on a Mac, right?
I believe so. No. It's Control Shift R from a Mac.
Oh, is it? Okay.
Yeah.
Oh.
Take your pick. It's artisanal. You can choose what you want. And this we are going to call starting with data. And we're going to press OK. And R is going to do this nifty thing where we have this whole header setting, which is cool because when we start typing something and we want this whole section to disappear eventually, we can press this button that's on line 74 where this section appeared, and it will collapse the whole section for us. There's nothing here, so it won't be terribly useful right now, but that's what that looks like. So it's a way of helping you organize and navigate through your code. So, so section headers are produced with Control, Shift, and R. And then the other cool thing that you can do is if I click down here, it tells me that I'm under starting with data. And because this is the only section that we have in our notes right now, I can only navigate to starting with data. But when there's more, you can jump around your code by clicking on those sections there. Yes.
I was taught if you do like 5 hashtags in a row in your comment, it also does the same thing. It's a little quicker for me, but
Cool.
If you just do the dashes and
Yeah. You can type them as well.
Pretty much anything over 4, either hashtags, dashes, I think underscores, equals, anything you do like in multiples of 4 or 5 will act as a section break. And I highly recommend using this because it's a really handy thing to use. The outline view is the upper right button. It might not show up here. If you look on the upper right of your script, there should be, maybe drag that window over and see if you can. This is really cool. There it is. So this little button here, click on that. This is a super handy way to, it does the same thing as this, but this is a nice way that will show you your your code chunks. And when we get into markdown documents or R markdown, I use this all the time. I don't leave it open, but I'll just click on it and like, it's a quick way to see like, all right, what's here and where am I? And that's a little outline button.
Don't have that run. Is there a way to make it appear?
So I think it's a newer version in R. It might be a version that's R Studio thing, which I know we talked about.
Okay,
Yeah.
we downloaded the new version earlier.
Okay. Yeah. I'll look at it. I'll look at it later.
Okay. So we have our section, and it's titled Starting with Data. So what we are going to do is start with data. And this is going to be the only thing that I'm going to ask you guys to copy and paste, but there is a download URL in today's notes underneath the header, starting with data. Oh, I don't know how to show you guys.
I think there's the upper left or right corner might do that, and then you click on the screen.
There we go. Okay, there it is. Everybody's highlighting it right now. So if you highlight this, this is how we're going to get our data today. Highlight it and bring it back into R. Sorry. Trying really hard. Okay. All right, and I'm going to fix the spacing on that because it'll look prettier. I think it will still run just fine without me fixing the spacing, but I want to do that. So the first thing to be aware of, the way that this is laid out right now is it's telling R to download a file using the download file function from the URL https and downloaderfigshare.com files, and then it says a number. And then this is a CSV, and we're telling it to put it in portal data join.csv in our data folder. So if you do not have a data folder that is spelled exactly like this, for instance, if your data folder has a capital D, then you need to change this because it's not going to work. However, R will give you an error message if it's not going to work for you, so that's helpful. So if I run this, it says trying URL, content type binary, downloaded, 2.9 megabytes. Please put up your green stickies when you have this downloaded.
And go check your data folders. This is something in there at this point.
It'll put it in this, or you can right now make it here. So make it the file.
Oh, it's just in it. Just says
So
it's working for a lot of people with capital T.
okay, so I just have to
Put it in the data folder one way or another, which is really
I thought I
interesting.
had to have a portal so you guys.
No!
Okay, that's good.
That's not supposed to work.
It's not supposed to work, but
That will break on your colleague's Mac computer. Okay, I misspoke earlier. It looks like almost everyone has this. I said download data into R, but I just changed it. It's download data onto your computer. So what this has done is it has taken the CSV file from the internet and saved it onto your hard drive. But R, even though it performed this computation for you, still doesn't know that this file actually exists, and it's not in R's working memory. So in order to do that, we have to give it an object name, and then we're going to use a function called readCSV, and we're going to tell it where the file lives. We just put it in the data/portal, and I'm going to use tab complete. I pressed tab and it appeared for me. And then if I run this, now we have brought the data into R. Yeah, so make use of that tab complete because that's a pretty long file name.
My tab doesn't work. So.
I got it.
Yeah.
Okay. So what's the first thing that we could do to see, like I ran this and it didn't give me an error message, but I have no idea if surveys is actually in R, what's the first thing that I could do to see if surveys is there? Okay, that's not what I was thinking, but let's do that. I was just going to say I could type surveys and run that. And it says max print, get option max print omitted 34,710 rows. So it looks like it's there, but not terribly useful. So let's do what everybody else told us to do and type survey or head, use the head function and use it on surveys. And I'm going to scroll up a little here. This should probably look better in your guys' screens. Maybe if I drag over a little bit, it'll be a bit better. But this is, I can kind of understand what's going on from using head. Here, I see that 4 of my columns at least are genus and species, taxa, and plot. So this is a data frame. What is this from what you just got to your console? What does this look a little bit like? An Excel spreadsheet, yeah, it's pretty similar. So the rows are the records, the columns are your variables. Who has worked with data frames in R before? By show of hands. Wow. Do you guys feel pretty comfortable with data frames in R?
No.
Okay.
Just imagine.
Okay. So we used head. What's another function that we could do? Like, this is a pretty big data frame. Printing it to the console wasn't super helpful for me to really get a feel of what type of data I'm working with. Another function that we could use is, sorry, I heard 3 people say structure, and that's what I was thinking. What did you say?
Oh, I said view. So how about
View.
Oh, that's cheating. We're not going to do that. View with a capital V. That will pop up, and you can view it like an Excel spreadsheet. Aggie, and it like, can you really parse that information when you have 34,000 records? Probably not. I don't know. Maybe if you're superhuman. I'll let you be superhuman if you want to be. So we're going to use structure, str, and look at surveys. I just heard someone say structure doesn't really help that much. I totally disagree. Look at how much information we just got out of this. Let me scroll up a little to get to the top. All right. I know so much more about this now. I know that it's a data frame. I know that I have 34,786 observations of 13 variables. I didn't know that before. I have a record ID. It tells me that's an integer. I have month. It tells me that's an integer, as well as day and year. I have plot ID, also an integer. And then we have things like species ID, which is a factor. And we see that we have 48 levels in this factor. That means that we have 48 different species. That's something that's good to know. It tells us a little bit about what some of those species might be, like A, B, A, H, A, S. Presumably, if you are a researcher, you know what these stand for. We have a lot of factors in here. And we have hindfoot length, all sorts of things. This doesn't look all that helpful, but from this download URL, or even just reading it into CSV, and then knowing now that you have 13 variables, and that this is ecology data, because you get it from species and plot type and that sort of thing, you know way more about this data just by structure than you did before from your download URL. Yes?
What is a factor?
Can you just hold on a hot sec? We'll get there, I promise. It's coming like
Couple minutes.
yeah, I'm gonna show you how to investigate a data frame a little bit more. And then I'm going to show you how to subset a data frame quickly, I guess, and then we're gonna talk about factors. Okay. I'm going to list off some more of these functions that you can use to investigate a data frame because they are pretty useful. And they all have a similar syntax where it's just a couple letters and then you give it the data frame name. So functions to investigate a data frame. The first one, let's say we want to look at the size. What do we think DIM stands for? Woohoo! Winner, winner. So we get 34,786. That's how many rows we have. So that comes first, and then we get columns, and there's 13. If we wanted just the rows, we can use n row, and then we get the same number. And then by the same token, we could use n col to get the number of columns. Oops, we should spell it right though. That would be important. And we get 13. We already saw head. What is the opposite of head? Tail. So it's useful sometimes to see if the bottom of your data looks the same as the top of your data. So that's what head looks like. And then tail looks pretty similar. We get some other stuff up there, but we still see rodent quite a few times. If we wanted to get at the names of something, there's one called names that we could use. What do we think this is going to give us? Yes, the column names. This is a synonym for col names when you're talking about a data frame. Sometimes these can act differently if you have a different type of data structure. Sorry. There we go. What about row names? How would I get those? Row names. So the row names here, this is important to know, are not terribly useful. So the default row names, if you did not assign row names to anything, are just going to be the index of the record from the original CSV that you put into R. So if you sort this, the index, this row name, isn't going to change. It will stay with the record that it was with originally, but you can reassign row names if you want to, and sometimes that's useful, especially if you're working with genetic data. But I won't go there right now. And then we have things to produce a summary of our data as well. We have structure, which we already saw. And then what's another function that we could use to summarize our data? Summary. Okay. And this might be more useful looking, depending on who you are and what you prefer, than structure was. So for instance, for species, we see that we have Mariami 10,000 times, Penicillotus 3,000 times. We see how many times we have taxa and that sort of thing. If we have a numeric variable like weight, it will give us the minimum, first quantile, median, mean, third, max, and the number of missing values. And we'll go over how to handle, well, Ryan will go over how to handle missing values in a couple minutes. Okay. Questions about these functions, how to summarize a data frame or get a feel for what your data look like when you're first reading it into R. Okay. So now let's go on to subsetting. So just like we use the square brackets for a vector, square brackets for a data frame as well, what do you think changes between a vector and a data frame now? It's multidimensional, right? So we have to specify 2 dimensions as well if we want to get back that type of information. So surveys, we put our subsetting brackets in. And then let's say I want the first record in the row and then from the first column. So rows go in the first position and columns go in the second position. And that gives us back the value 1. I think that's an ID number. That's not terribly useful, so let's look at something else. What if we want, let's see what's in the first row in the 6th column instead. NL. And then we get back 48 levels, A, B, A, H, A, S, B, A. So this is a factor. When something prints out the number of levels, we know it's a factor. Again, we'll get to what that is in a second.
And the NL is the column name, right?
No. What do we
That
think?
cell,
Yes,
right?
it's the value in that cell. Let's look at names of surveys, but I only want back the 6th thing because we're talking about the 6th column here. So NL is species ID.
So is this because you have already delineated that the top row is row names?
Oh, okay. Is this
If it
because,
wasn't, then
yeah.
it would show that up, right?
yeah, so is this because I already delineated that the first row is column names?
Yes, sorry,
Yes.
that's the one.
When you
Yeah, yeah.
When you use read.csv, the default is that it says, okay, this first row in your data, I'm going to assume that those are column names. You can override that by saying header equals false. I think we'll go over that a little bit later as well, but the default is that it will say, yes, this first row of values is your column names. So that's how it already has that information. Okay, so I can get back individual values, but what would be better to get back sometimes? What might I want back from this data?
Certain columns.
Only certain columns, yeah. So that's something that I do all the time. Let's say I only want back that first column. I still use my subsetting brackets, but this time I don't put anything for the rows, which indicates I want all of the rows back. And then I want the first column, so I put a 1 in that space. And if I run that, it gives me back a vector of all of the values in that first column. So blank indicates that I is casting a wand and
Just. Oh, oh. So the screencast must have. Hang on, everybody, or you can continue to.
figure out with your neighbor. I gave you back a vector of the first column. Figure out how to get back this first column as a data frame. Go. You are not equipped with the skills to do this, so just try and figure it out.
That's not good. What's happening?
I did it.
record,
Game 2. Chat.
So instead of having it all like, yeah, so like that's, yeah, so instead of that. So
I did not do object assignment. If I assigned it to something, it would be a new data frame.
Right, so it's not in your environment.
It only printed to the console.
How does it know they talk about the first column?
How does it, so, okay, so here I have explicitly stated I want all of the rows back by having a blank here. And then I want the first column back. And using this notation, R printed out a vector to the console. R decided, the makers that be of R decided that using this notation with the data frame, where you have only one number with no comma specified, is going to refer to columns. And when you use that notation, you will get back a data frame, which I can see when I printed over here looks different than what a vector would look like. My console is really small, so it's difficult to see that there's multiple columns here. Or no, there's not multiple columns here, sorry. But the readout is large, but it might look better on yours. So try and run this one first and see how different that looks from line 109, how different that looks from 111. Yes, I had a question. Can you take multiple columns? How? So go ahead and, do you want to say that louder? How did you do that?
Colon,
1 to 6? So go ahead and try that. Which one are we going to try it on? This one or this one? This one. So try and type surveys 1:6 and see what printout you get. And someone tell me if that works.
Yeah. What about?
Wait, did it work?
Yeah.
Okay. Okay. What about what?
What about if you don't want them in a row?
What do you mean?
Like you want 1 and 6.
Oh, okay. So, or maybe you want like 1, 4, 3, 6, 2.
Right.
Okay. So remember that little C that we were using before? So try and use that and put them in whatever order that you want and see what happens. Is it still working?
It's recording audio, but not screen sharing it. But I think we'll just go with that for now.
Okay.
It's weird. This happened to Mike the other day. I don't know why.
Okay.
So anyway, I can try when we switch over.
Okay. Okay, so let's review what we just went over really quick. Yes.
So that, not only just on the you're talking about columns, it also is reading that as a data frame. So if you named that object, it would be a data frame.
Correct.
You made it.
Yeah.
Okay, so let's do this first one here. So I have surveys 1, but let's say I want surveys 1 to the 6th column. I want them all back. That went by really quickly on my console, so I'm going to do it again. But that printed out 6 columns to my console, so I got them all back. The other option, if I wanted 6 columns, but I want them in a different order, let's try this. If I use the combine function inside of my subsetting brackets, and let's say I want the first column, and then the third column, and then the 5th one, and that's good enough. Let's see what happens. That also printed them to my console. So you can use this notation to get a data frame back of whatever columns you want out of your data frame. So it's a way to subset, yes.
Could you also, instead of using the like position, could you use the column names that are the headers?
Yes, we'll get there in a second. Can you use the column names that are the headers? Yes, you can. In a different way, and I'll show you. Yes.
How is it certain that we're calling columns rows?
R is magic. I don't know. They decided when they wrote the programming language that this notation was going to refer to columns.
So if we wanted to call rows 1 through 6, we would have to use the comma.
Yeah, so we would do surveys 1 through 6. And then let's say we want all columns. That's what we would do. Okay, so this is wonderful, but like, let's say I gave you a data frame that had 30,000 variables in it, and I was like, please give me back species. And you're like, I don't remember if that's number 18,706 or 19,706, and I don't want to scroll through and check. What you can do there's a couple different ways that you can do this notation. So let's do subsetting a data frame with column name. So we could take surveys, and then the first way that we could do this is with our brackets, our subsetting brackets, and inside we could take something like species ID. And let's run this. And we see that we got the column species ID back, and we got it back. It printed a data frame to our console. We could also, by the same token, be more explicit. And we could say we wanted all rows back from species ID. And even though this is more explicit saying we want all rows, it also gives us this back as a vector instead. The way that it's printing to the console is different than when it was giving it back as a data frame.
Rows then, right? So the 1 through 6 this is as a vector.
If I did 1 through 6
Well,
and then
just
species
how
ID.
how we just denoted it on line 116.
Oh, so let's run this and see. This comes back as a data frame. Why? Because
Because it's more than one.
more than one
Yeah,
dimension.
Just kidding.
It can't collapse. If you're calling only one column, it can collapse that into a vector, but because this is multidimensional, it keeps it as a data frame.
My actual question I was trying to ask is if you do if you had just like 1 comma nothing, would that come back? That would come back as a vector, correct?
So
I think we made
is that
yes.
still multidimensional, comes back as a data frame. See, we have the column names, and then because we have both the row and then we still have the column names there.
Okay.
Yes.
What if you wanted to get only, say, flat types of control and still have it as a data frame? Is there a way to subset the rows and columns?
Hold your horses.
Yes. So some of this we're going to talk a lot. So there's lots of ways to do this. We're going to practice a lot more. We're going to use dplyr to do some additional things that you can start chaining a lot of those things together and pull out whatever you want. So yes. So the answer is yes, and we'll show you in a few minutes, right? Yeah.
Okay. 2 more on how to subset by name. And then I'm going to talk about factors. So surveys, we can also do double brackets and then put species ID inside of that. And this changes what we get it back as. So this gives us it back as a vector as well. I don't almost ever see this notation, but it's good to know that it exists. And then the last one that I see, or sorry, surveys, that I see and use all the time is this $sign. I type the $sign, our tab complete, I think that happened automatically for me. Tab complete popped up, and I can scroll down, and if I want species ID, I can select it. And then that gives it back to me as a vector as well. So the $sign is super helpful when you want to access part of your data frame. What? Save. Save. Save.
Good question.
Yes.
So, row 1 or the 122 and 123 are functionally the same, or they're doing different things? The code.
Their output is the same.
Because it's
Ryan,
Yeah.
challenge or
But it's
factors?
just the same.
Just go to factors.
Okay.
We have like 20 minutes left, so.
Okay, so factors, this thing that we've been talking about that are like ephemeral, and what even is that? That's the sort of last data type in R that we need to talk about. So we see down here, every time that I've been printing out species ID, this thing called levels comes up. So it prints out PEPEPS for whatever data we have saved there, omits some of our results, and then tells me that I have 48 levels. So factors in R are this really special thing where it's a way of representing a categorical variable. And when you have a factor in R, that categorical variable is seen underneath the hood by R as a number. Casting of your variables in your statistical models, where if you had male and female, males are 1 and females are 2, or vice versa, whatever, 0s and 1s, whatever you choose, you're representing your categorical variables with a number. But the handy thing about factors in R that you can do is you have a character string attached to that categorical variable that R sees it as, so you have information about that as well. Because this would not be handy if here it said 16, 16, 16, 16, 17, 17, 17, 17. You have no idea what that means. And if you have 48 of those levels, it's really difficult to keep track of what each of them are. So instead, R attached this little flag to those castings that it does so that you can see what they are, you can remember what they are, but it still works underneath the hood with all the statistical models that require you to cast your variables to integer numbers. Questions about factors? Yes.
So when you loaded the CSV into R, did R interpret the ESP, et cetera, as a factor, or did you have to tell R that it was a factor and not a character?
Yeah, so the default behavior of read.csv is to interpret your characters, character strings, so any words that you have, as factors. However, if we had given it a file name and then given it the argument, I'm going to scroll down here to find it because I always spell it wrong. Actually, I'm going to start typing it there. String as factors. This accepts a logical argument, and I could have typed false, and this would totally change our data because it would then count these DSs and PEs as characters instead of as factors. Factors are really handy because it allows you to do certain things with your data. For instance, splitting it into pieces that you can't do as easily with characters. So sometimes you want your data to be in factors. Like, no, that was text. Like, it's not a factor. Stop. And you could use string as factor equals false to get the behavior that you want. Later, this is base R. We'll go over a thing called tidyverse and tidy data. This is in subsequent lessons where the behavior will be a little bit different, and we'll talk about this again, and the pros and cons and when you want to use it. But for now, suffice to say that you can use string as factor equals false if you want characters that I've taught you today.
There's a whole bunch of functions that are as dot something, right? So as dot character, as dot factor, as dot numeric, as dot date. And they all allow you to convert any given column. Say like you bring it in as all character. You're going to go, oh, actually I want this to be factor. You can use as dot factor for that specific column using the subsetting or $sign or any of those options to convert columns back and forth. So even if it comes in as one thing, you can always convert it afterwards to something else. But it's important to know the default behavior that, like, when it comes in, what is it?
So switching to a factor is relatively easy. Switching from a factor to something else is tricky, and we will talk about that later as well. Right now I'm going to show you how to find the number of levels and what the levels are, and then we're going to be done with factors for today. So the functions to do that are levels, and we're going to look at surveys and species ID and see what that gives us. So it tells us each of the different levels that we have. So of these 33,000 some odd records, we have 48 of these levels. And it tells us, and notice that they're in alphabetical order, that is the default for R. And this order that it returns to you is going to be, so AB is going to be seen by R as 1, AH is 2, 3, 4, all the way down. And you can change this, but we'll talk about that also at a later time. And then to get the number of levels, it's in levels. R's helping me, so I'm going to press tab. And same thing, surveys, species, ID. And we have 48.
Just table really quick.
Oh, yes. So factors allow you to do this wonderful thing. If we take surveys, And species ID. Aww. Oh, that's a horrible printout.
Yeah, it's not great, but yeah, table is handy. Table works for pretty much any data type, and it's really great. But factors in particular are handy because it will pull out all the different levels and tell you exactly how many records you have of each. Okay, so it's super handy to quickly. And that's another like one I use all the time when you're kind of bringing data in. You're trying to figure out what's there and what pieces are stuff. You know, that will also tell you if you have sometimes like things that are misnamed, like maybe you have a species that's named the same thing, but it's two different names, and you can see that using that sort of option. So tables are really handy command.
Questions about factors?
Thank you. All right, so now in 15 minutes, you're going to learn dplyr. Probably not, but we're going to introduce it to you. Yes?
I was going to say, did you mention the is.factor as well?
Is.factor to check if it is a factor? Yeah. There's a bunch of other functions. There are is dot. So as dot and is dot are both, you'll see, so is dot factor surveys, so let's say plot ID, just for example, false. So if you wanted to check. I don't use that one as much anymore because you can often just, if you have it here, you can click down and just see, you know, species, it'll tell you right there. But there's a lot of functions that you can use within writing functions. You want to kind of know, like, check if this data type and then do something. You can use things like that. That's a good point. All right, so let's jump into dplyr. It's going to be a largely an introduction. We're not going to be able to really jump in too much to everything that dplyr does, but we'll have plenty of time. We're going to be working a lot with dplyr going forward, so and I'll probably send a little assignment out for you to all work on. So I'm going to switch over to the lessons. So I'm going to be under course materials, and we're going to be in dplyr ecology. Okay. Okay. So dplyr. So whoops, that's not what I wanted to do. One of the cool things about the tidyverse, and so you'll hear a lot more about this, the tidyverse. A show of hands, actually, how many people were able to successfully install that package on your computer? Most everybody. Okay, great. That'll save us a little time. So the tidyverse is a whole series of packages, and packages have functions in them, right, that do stuff. And so we are going to use dplyr today, and a little bit tidier next week as well. But basically what dplyr and tidier do is all the tidyverse functions are written in the same way. So the nice thing is once you learn kind of one package, it's much easier to sort of interpret the other ones because all the functions behave similarly and they play well with each other. And ultimately, I think what you'll find, what we will use a lot of is ggplot2. Which is, I would say, probably the premier default visualization package. That's why people learn R, is to use that package. And I'll show you a lot more really cool stuff with ggplot later. It's amazing, and I've published papers now using ggplot, and it's great and really customizable. So anyway, the nice thing is dplyr and tidier, they feed very well into ggplot. One of the things that Taylor mentioned, and is one of the main reasons that they've sort of built this set of functions, is sometimes base R functions have sort of hidden things that you're not really sure how they're evaluating, like Reese's question about the columns, why did it do columns? I don't know. I know somebody here who works at the DSI who could tell you, Duncan, but most of us probably that's not super, like not something we're gonna be wanting to learn immediately, right, until we're a little further along. So anyway, one of the things that this does is sort of remove that abstraction and just make it really clean and easy and make the default consistent across all these different packages. All right. So what I'd like everybody to do is we're going to start here. We're going to load our tidyverse package. Okay, so adding a section. Okay, so library, tidyverse. There's a lot of tidy things here. Okay, so green stickies up if you have that loaded. Okay, and now what we're going to do is use a function that's part of the tidyverse. That's from the reader package. And I'm going to show you a different notation just so you know what package this is coming from. R is the library or the package. To access a single function in any package, you can use this : option. This is really handy so you kind of know exactly what you're calling, what function you're calling. And for us, we're going to use read. You'll notice here's all the tidyverse. You'll start seeing all the functions typically are something underscore something. That's how they're all structured. Whereas in base R, a lot of things are structured with a period, right? So that's one quick difference. We're going to use read underscore CSV. Okay, and then we're going to let's add our data and our portal data. Joined, is that the one we were using? Yeah, okay. Okay, so let's run this. Actually, call it surveys in the front of all that. So remember how we did the read.csv and how it brought everything as factors, right? So let's run that. And now you'll notice the printout. A lot of the tidyverse have really handy, very clear printouts. So it tells you exactly what it did. So it parsed these columns by these things. And it says, okay, here's all the columns, and here's what they are. Integer, 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 hey, character, character, character. So no factors. So the default for read underscore CSV and for the tidyverse is it will read in all of your data as character. The reason is so you can sort of, it's as Taylor said, it's much easier to make something into a factor. It's a lot harder to make it not a factor, right? To remove it as a factor. So that's why the default behavior is what it is. Other than that, it's the same deal. Read underscore CSV tends to be really quick with large data sets. I will say I've used it for some really big data and it works really well. Okay. So now we've sort of done structure and all those other things. So let's talk about dplyr. So there's about 5 main verbs in dplyr that we're going to talk about. dplyr uses these to manipulate the data. And so let's show select. So verbs of dplyr. So select. Yes.
I know you said this, I missed it. The R : what is that?
So that is just saying use this package and then the function that's in this package. So it's a specific way to say, I'm just putting that there so you know where this function's coming from. But because you already loaded tidyverse, you don't need this necessarily. Correct. Yeah. Sorry, I should add a note. Okay. So let's use select really quick. So let's, all these functions have the same structure. So they're going to be a function and they're going to want the data first. So our data is what? Surveys. Okay, comma. So that's the first thing. The next thing is, let's say we want to select just a few columns from our big data set. So let's say we want plot ID. Notice I don't have to quote anything. This is also a really handy thing. Say plot ID, species ID, oops, and weight. Okay, so I just want those. So let's go ahead and run that. There you go. So that's all we need. So you can see this is a little simpler versus the bracket option, right? And you can see, the nice thing is you can see exactly what's happening. So I find it really easy to share code with folks and they can read it and see kind of what you did versus bracketing and numbers. But both are doing the same exact thing. You'll notice this thing says a tibble. A tibble, the only thing that you need to know about tibbles, they're data frames. Okay, it's just it's a new term for a data frame. With the main thing that the way it's interpreting the factors and as characters is the default is as character. Okay. Beyond that, you don't need to really worry about tibbles. They're just it's a data frame. But the nice thing is the printout gives you a little more. It basically gives you the structured data inside of the printout. So integer. All right. So any questions on that? With green stickies, if everybody was able to do that, yeah. Okay. So now let's show how to choose something with filter. So select is a way to choose columns, typically, right? So that's what we're going to use select for. So let me add this to. But filter is a way to choose rows. And the cool thing is you can start chaining these commands together, which I'll show in a second. So let's say filter surveys, and let's say we only want 1 year. So we're going to say year is the column we're interested in. And then the double equals is the equality, right? Instead of a single equals would mean an argument. So main difference there is this allows us to pick 1 year. So let's say 1995. Okay. Let's go ahead and run that. And you'll notice we end up with a tibble, and it tells you the dimensions right here, which is nice. 1180 by 13 columns. So that many rows and that many columns. So this is a super powerful way to start doing this. So imagine, let's say we only want June, like all the surveys from June. How would we do that?
Filter.
So filter, surveys, month, 6. Here we go. So hopefully we have now a data frame that has 2635. And you'll notice now the month column has only June. Okay?
So could you select only certain columns and filter?
Exactly. So now we have these two main things. So I'm going to tell you how to chain these together. So bear with me. We have like four or 5 minutes. I want to cover one last thing today, and then we'll deal with some of the other verbs later. But this next one is really powerful and really cool. The tidyverse that works anywhere in R. So this is called the pipe, right? So Magritte, or Magritte, if you are French. I'm probably saying that really awfully. I apologize. But they use a pipe, okay? And a pipe in R is quite a bit different than a pipe in other things. But let's add a section that says pipes in R, okay? So use command or control plus shift plus M. That's a pipe. So it's a %, greater sign %. And the way that this works is if we want to make a new data set, oops, it could be, it doesn't matter. So you're hitting shift. Yeah, sorry. Just M. Okay. So to chain this together, let's make a new data set like we were asking. So we're going to assign that data set a new name. I don't want to name it the same thing. Why is that? It overwrites it, which is not a big deal because I could always bring it in all over again, but it's better to sort of start with something clean. So let's filter surveys. Let's say weight greater than 2. Return all the rows with weight greater than 2, right? Okay. Now instead of, I could assign this as surveys 2, or, and then do something else, and then sort of keep filtering from surveys 2, is add this pipe. So Control or Command Shift M, and you'll get that little pipe at the end. Now if I hit Enter, I want everybody to see, look, it's indented here. That means R is waiting for something else. The other thing you'll see is this scary red X. That's okay. RStudio is really handy in that it helps you debug your code automatically. And if I hover on that, it says unexpected end of document. This will show up if you have a missing comma or a parentheses. It'll say missing comma or parentheses. So it's actually really informative and it tells you something. In our case, we just want to add another thing. So we're going to say select. So now we've filtered by something, and let's say we only want the species ID and sex and weight. Okay. So notice what happened here that's different. Yeah.
You don't have to put the surveys in?
You don't have to put surveys. And why do you think that is?
Does the pipe remember that?
This thing. Yeah, so the pipe is basically saying everything that's on this side gets passed to the next line. It just ends up going past the next line, okay? So it's getting piped into the next command. And so I would say you can use pipes as much as you want. It works in anything in R, really. But you have to be cognizant. If you string more than like 3 pipes in a row, I would say pause, take a break, assign that, and do something different to help sort of debug your code. So let's run this really quick.
So those are all just nested within each other. That's what pipes is doing. It's like nestering those.
Yes, exactly.
Do you know,
Makes sense.
A pipe will always go to the first argument.
Then only until that
Yeah,
takes
so if you give them
That's it, arbitrary.
So if we look in our environment, we have now surveys 2. And if we look at that, we only have those columns. Okay? All right, so it's 4 o'clock. I know we sort of threw a bunch of stuff. We'll cover this in way more detail next week. I would love if everybody could go to the Google Doc and do the form, fill out the survey of kind of what worked today, what didn't.
You want us to post our change?
I will send you an email. So, oh, one other thing, really quick. Everybody listen.
Yes.
Everybody listen. Okay, so we're going to do something different. I'm going to send a little challenge that we've sort of already done using the same commands. And you are going to have to do that challenge, push your changes up to GitHub in your script. And then I'm going to assign somebody to go grab your script, read it and run it, and then make a comment about it on issue, okay? So that's going to be our assignment for the week. But I'll send an email or a message about that.
And you want that as a separate script than this one?
No, well, I'll send an email. It can be the same if you want. It doesn't matter to me. All right, so if everybody can fill out the survey at the top, please, that'd be great. End of class survey. Thanks, y'all. Thanks for sticking with it.
Well, they have